Good morning, everyone. We're gonna look at the quadratic spline method. Okay, my camera is having some issues focusing. I hope you guys can see. Okay, just a second. Okay, yeah. So we have two sets of data points, x and y. Now, why is the t written here? Because in the example, it was t and y, but most people normally use values of x and y. So to make it understandable, this is the independent quantity and this is the dependent quantity. This, in our example, was temperature. Now, what is the quadratic spline method? Basically, we have to form these four equations, okay? And why do we have to form four equations? Why not 6 or 8 equations? Well, it all depends on the number of data points given to us. In the question, only 5 data points were given to us. So we formed a total of 4 equations for all of these intervals. So from 82 to 100, we have this equation. From 42 to 52, we have this equation. And this is very handy when we want to make predictions. So as you can see, we have 4 equations and 3 variables, a1, b1, c1, a2, b2, c2 per equations. So a total of 12 variables. Now if we want to find out the values of 12 variables, we'll need 12 equations. So first of all, how do we get these 12 equations? Well, 8 of these we can get by the simple fact that these splines, these lines, will be passing through 2 points. Now these points are governed by these equations that we just introduced. And as you can see, the first spline will pass through 2 points, 22 and 42. The second spline will pass through 2 points, 42 and 52. These are the points where it begins and ends. So we have a1 into 22 whole square plus b1 22 plus c1 is equal to this. Now where did this equation come from? We're just taking this equation from here and plugging in the values of t and putting it over here. Remember I said each spline passes through 2 points? Well, in the case of the first spline, it was 22 and 42. That is why we have 22 and 42 over here. In the case of the second spline, that's 42 and 52. In the case of the third spline, 52 and 82. And finally, in the case of the fourth spline, we have 82 and 100. So we're able to come up with 8 equations. Remember, we have 12 variables, so we still have 4 equations to go. Now, how do we find these 4 equations? Well, 3 of them we can find by the simple fact that the slope at all the intermediate points is going to be the same. Now, what does this mean? This means where this spline ends and this one begins, the slope will be the same. Similarly, where this one begins, this one ends. Sorry, where this one ends, this one begins, and where this one ends, this one begins. So we'll get a total of 3 equations because intermediate spline will only occur at these 3 points. Now, how do we form these equations? Well, as you know, the derivative of an equation is basically equal to the slope. So let's say we have this equation over here. We're gonna take the derivative of it. So the derivative of this equation is going to be 2a1t plus b1. Since c1 is a constant, it equates to 0. So now let's move over here. And as you can see, we applied the derivatives directly. Now, where did all of these terms come from? Well, remember I said that the slopes at the intermediate points will be the same. Well, that means the derivative of this equation will be equal to the derivative of this equation at t equals 42. So we have t equals 42, so both of those terms came from this side to this side, so that's why these two terms have a negative sign on them. The same will be true for 52 and 82, and that is how we get our 3 equations. For our fourth now this is all the equations we could come up with the given data. So for the fourth equation, we come up with an assumption. We say, hey, the first spline is linear. So that is why a1 is equal to 0. Now, how does equating a1 equal to 0 make that spline linear? Well, again, let's move on to the equation. if we make a1 equals to 0, then there is no more t squared. There's only b1t plus c1. So the highest power is 1. And as you know, in linear equations, the highest power is 1. So when we say a1 equals to 0, we're basically saying that we've assumed the first spline to be linear. Now we have 12 equations. Now, if you have 12 equations, that means we can come up with the values for our 12 variables. Now, how do we do that? Now, 12 equations, 12 variables, easy to solve. You can simultaneously solve them. So this huge matrix is the second way to solve it, through matrices. Now, most probably you're going to get a computer program to do this, because doing this by hand will take you hours, like it did me. So what did I do here? I just took the equations from here, from 1 all the way to equation number 12, which was this one. And again, as you can see, this is a 12 by 12 matrix. You have all your variables lined up over here, and you have all the values of y lined up over here. These are the only unknowns. So if you solve this, you will get these values. Now, what is the point of getting these values? Well, we can take these values and now put it into this equation. Now, if it is asked of us, what is the value for y at, well, t equals 77? Well, 77 occurs between 52 and 82. So we will use this equation, a3, b3, and c3. And as you know, we already found out the values of a3, b3, c3 from over here. So we'll be able to make a very accurate estimate of the value of y at t equals 77. I hope this video helps. Thank you for watching.